Hi, in this project, we will make this word of the day display. It fetches the data using internet from dictionary.com and display the word and its meaning in the dot matrix display. As soon as you power it, you can see that the LED is blinking, showing that the module is attempting to connect to Wi-Fi. And if the LED is glowing constantly, it shows that it is connected to Wi-Fi and is currently fetching the data. If it turns off, that means it has fetched the data, disconnected the Wi-Fi, and now it will display in the dot matrix display. On the laptop, you can see that the word displayed on the dot matrix is indeed the word of the day at dictionary.com. The parse list is not too much in this project, and hardware connection is also pretty easy. The major aspect of this project is the program itself, so let's jump right into it. About 2 years back, I tried using ESP01 Wi-Fi module, but we couldn't be friends. Until then, I haven't used any Wi-Fi module in any of my projects. But at one point or another, I will be requiring to use Wi-Fi in my projects. So I thought it is a good time to do so. But this time, I decided to use NodeMCU module, which is a lot easier to use than the ESP01 module. To get acquainted with it, I used many resources from the internet, like this Kevin Dara's video, the free Internet of Things class from instructables.com, and the method of connecting to internet and fetching the data from it is partially based on this sketch right here. Okay, let's Google word of the day. You can see there are various websites that have a separate web page dedicated to the word of the day. I decided to go with dictionary.com. This is today's word and this is the meaning of it. Now, if we directly call this web page from the ESP8266 module, we will get all this crap. Just imagine the size required to store all this data. I think that the ESP8266 module cannot even handle this much data. We are only concerned with this part of the data and the meaning of it, which will also be here somewhere, but we don't care about that right now. So I'll close it. To do that, right click on the word you are interested in, click Inspect Element, and the browser will highlight the code responsible for the word. Now after this, you will copy its XPath and you will go to thingspeak.com. Go to apps, thing HTTP, new thing HTTP, name it something. The URL will be the URL of the page, which is this. Paste it. Select the method to get HTTP version 2.1, and on pass string you will paste the XPath that you just copied and paste it. But after looking at it, I thought that this will not work. I inferred that this is the pass string for the day only, and I was right. The second day, this pass string didn't work. No matter how much I tried, I just couldn't get the correct pass string from the Chrome. So I switched to Mozilla Firefox. Again, I clicked Inspect Element, hover over different codes so that, yeah, here it is. Copy XPath. Replace the pass string with it. And now looking at this, I get a good feeling and it actually works. I have it already set up right here. After saving it, you will see something like this. And if you open this link, it will take you here, which only has the word that we are interested. If you view page source, this will be the data you will be getting if you just called this web page from the ESP8266 module. But we can easily filter that out as it is not much. So in the beginning, I created separate links for word and meaning, you can see here. But I noticed a problem while doing the coding. It is not easy to call different web pages and store the data from the web pages into different variables. So I had to create a new thing HTTP which displays the word and the meaning at once. I again moved to Mozilla Firefox, hovered over it, and found this. So this is the code responsible for the word and the meaning together. I copied its XPath, and I think that will be it. Yes, you can see they both are same. So this is a pass string for the word and the meaning together. If we open the link provided by the thing HTTP, we can see that we have word and the meaning. Let's view the page source. Now we will have to filter all this out, as we want only this and only this. Okay, now let's test the functioning of the module. But before that, let's understand a bit of a code. For that, open Arduino, go to Preferences and add this link to additional board manager URLs. Click OK. After that, go to Boards Manager. Wait for the index to load. Search for ESP8266 and install it. Then close it. Okay, so this is the code we'll be using for now. Insert your Wi-Fi name, which is the SSID here, and if it has the passkey, insert it here or leave it blank if it is open. This is the host that is providing us the information. Change this to D0, which has the internal LED and will tell us that it is connected to Wi-Fi or not, or it is attempting to connect. We create an object which will help us throughout the code. Serial.begin, you know what for it is. Connect Wi-Fi. This function is defined all the way. No, this function is defined here. Okay, so this attempt to connect to Wi-Fi. It's all just functions and functions. As the library is handling all this, we don't need to worry much. When it is connected, turn the LED high. Actually ESP8266 module is an active low module. So if we want to turn on the LED, we have to change it to low. And if we want to turn it off, we have to change it to high. So let's find where low was here. Let's change it to high. Okay. After connecting to Wi-Fi, we check if we can connect to the web page. This get page function is defined all the way down here. This is the format to connect to the host. Get space apps.thing http blah blah blah, and this is the API key. You can either just copy this API key and paste it right there, or you can copy from here. Don't forget the /. You can copy from here and paste it to here. HTTP version 1.1. Okay, if the website responds, return true. If it's not true, we will see in serial monitor get request failed. Setup ends. We have entered into the loop function. If client.available, until the data is coming from the website, store it into the character constant C and then print C. As soon as the data sending is completed, we get out of the loop, print a line, and then stop. Then we disconnect the Wi-Fi. Okay, so after you upload it, the results should look something like this. This is the final sketch I came up with for the project. This too we have seen previously. Adding the library for controlling the dot matrix displays, which also require SPI library. Maximum number of dot matrix display you have connected. Pin definitions for the dot matrix display, which is the SPI pins of NodeMCU. Wi-Fi SSID password. Some variables for storing the coming data. There are also some arrays. We will see in a minute. Alright. Host site API thingspeak.com, LED, Wi-Fi object, dot matrix display object, delay time, scroll text function for scrolling the display in the dot matrix. Originally, I wanted to use this function to search for the keywords that will help me filtering out the word and the meaning from the source code. I tried using it on Arduino, it worked perfectly, but for some reason it didn't work on this ESP module. So I had to drop that idea, and let's remove that part from the code. These are the remains of my failed attempt of using two different web pages, getting data from them and storing it in two different variables. Actually, I'm not qualified to say that it doesn't work. So if you guys know how to do it, please let me know in the comments, but we will remove it for now. We are inside loop until the data is available. This time we are not displaying it in the serial monitor, but this time we are storing it in source code. After the loop is completed, the source code variable will have all of this, through which we will have to filter this one, the word, and this one, which is the meaning. You can uncomment it and upload it to see if data is coming or not. Now after this, I went to Arduino site to see what I can do with the strings I have, and this is what I found, which is a lot, and I had to go through each one of it. Actually, I know a few of them beforehand, but most of it I had to go through it to decide whether I can use it for my purpose or not. And I found one, which is this, the remove function. It removes the characters from the strings. You just provide it the index point, the start point, and up to how many strings it has to remove. So I can easily put 0 in place of index. 0 will be this, and count up to here and place it instead of count, which will remove this part from source code. To count it, I just copied it and use this free letter counter, paste it, and count characters. 216 it will come. So I did the same, remove index 0 up to 217. You'll see that here it is 216, but I have used 217 because a letter was remaining if I used 216, and so I found this number 217 by hit and trial method. Now this is the final sketch, but in my previous sketch I also removed this middle part, and it worked completely fine, but for that day only, because on the second day I found that when the word changes, this does not remain constant. Although this part remains constant, this part remains constant, but this part does not remain constant. So we cannot generalize a logic that will remove this part completely every time. So I had to come up with another method. But as we are sure that this is the same every day, this is the same every day, we can remove it. I just copied it, pasted it right here, counted it, comes to 61, and from the end I remove 61. Now how this works is, we have already removed the first 217 characters, which is these. We have removed this much, and now we are left with this much. So I can easily get the length of the remaining characters in the string using the function string.length. Here, string.length, and we also know that this much is 61. So if we subtract the complete length from this much length, we will get our index point, we will get our starting point. That's what I did here. Now we have our index, we have our starting point. We can remove the 61 characters from the string, this 61. After doing this, we will be only left with this much of data up to the full stop. Now we have to remove all this which is not required. A quick note, the function scroll text only accepts arrays as its argument to display the scrolling text on the dot matrix. We cannot call the scroll text function and give it string like source code and show it in the dot matrix. It cannot do that. We have to convert it into array. So that's what this function does. Source code, the string that we have to remove into array, the destination array, the length of source code +1. I also found this +1 by hit and trial method. So now in source code array, we have our array containing this much of data up to the full stop. Now the function starts with the word of the day itself. We'll copy the complete source code array into the word of the day array, and we will only copy the first 15 characters. After copying, we have this much of data in the word of the day array. Alright. To remove it, I used this method. It's a for loop which cycles through every word of the array word of the day, and as soon as this bracket character comes, the temporary variable sets to 1, and if it is 1, set all the data from the word of the day array to 0. That means it has nothing. In this way, we filtered word of the day, mythoclast in this case. And I used the same method to store this much of data in the array named meaning. After we have got our array named meaning, which has all the things which don't require and we have to filter only the meaning out of it, I used this method to filter it. Again, I used for loop and cycle through all the different characters in the array meaning, but this time I did not search for this angular bracket. I searched for the word span, span. Why I did that is because you will see that in the source code, span only occurs once, and it is just before the meaning of the word. So I searched for span, and as soon as we found span, I set all the characters prior to the word span 0, including this angular bracket. After which we will only be left with this meaning and all these characters which we still have to filter out. So to filter this out, what I did was, if we found the word span and after that if we found this angular bracket, we set all the characters to 0 after that index. So when this loop ends, we will only be left with the meaning of the word in the array named meaning. While true, that means this loop will run on forever. And inside this loop, we display a text on our dot matrix display, wait for 3 seconds, and display the meaning on the dot matrix itself, and wait for 3 seconds and do the same task again. That means to update the word and its meaning, you have to restart the module, but you can easily change it. This is the complete logic for the project. So that will be all for this video. I hope you learned something. If you have any tips, any ideas, please let me know in the comments. Thank you all for watching. Till next time.